Hello dear students, this is Dr. Saurabh's classes and our contact number is 98367930076. Again I am telling that, which is 98367930076, and our email ID is saurabhclasses@gmail.com. Please feel free to contact via these contact details, and we will help you out from your mathematical doubts or anything. So, and I am eager to tell you that we are going to organize a batch that will help you for the preparations of TIFR GS, NBHM, ISI, CMI, etc. Okay, please feel free to contact on the via this contact details. Okay, now we are going to solve a mathematical problem which is appeared in the question paper of TIFR GS 2025. And the question is telling us that a square, sorry, we can call it S2, which is what? So our x, y, z belongs to RQ when our x square plus y square plus z square is equal to 1. And let our D be the restriction of a Euclidean matrix. So our D be a square cross a square to R be the restriction of Euclidean matrix on R cube. So if our is a map from a square to a square such that distance of fx minus fx comma xy equals to the distance of x comma y. Now for all xy belongs to a square, then f is surjective. Okay, so how can we do that? Yeah, I think it's visible now. Okay, so now we are going to give something. Yeah, so now we are going to see some properties of f. So the condition which is given in the question is my distance of fx comma fy is equals to the distance of xy for all xy belongs to a square. Means that f preserves distance, and f is an isometry of metric space SD. Sorry, S2D. Yeah. And now isometry is on S2. Isometry is on S2, and isometry of the unit sphere S2 in R cube must preserve the structure of S2. Isometries on S2 include rotation, reflection, and the identity map. So these transformations map points. Let me write it. Rotation, reflection, and we know that which is identity map. Okay, so our these transformations map points on S2 to other points on S2, and they do not shrink the sphere. Okay, now injectivity. Let me change my color. Okay, yeah. So now we are going to see about the injectivity. So f from a square to a square is injective because of why? Because my if fx1 is equals to fx2, then distance of fx1 comma fx2 has to be equals to distance comma x1 and x2, and as this is same fx1 and fx2, so this distance will be 0, and then our distance of x1 comma x2 has to be 0, so our x1 has to be equals to x2, so it is injective. So now the image of f. So image of f is an isometry. It preserves distance and maps S2 to itself. The image, yeah, must also be a closed subset of S2. Yeah, because f is continuous. Now we are going to see about the cardinality of A square. S2, cardinality of S2. So the sphere S2 is compact and F is injective. Okay. So now, therefore, our F maps S2 onto itself bijectively. F maps S2 to S2 and this is bijective as it's compact and F is injective. So however the compactness ensure the image F of S2 is equals to S2 making our F is surjective. So this is a true statement. So our conclusion is that the statement given in the question is a true statement. Because it preserves distance of S2 and maps points on S2 to other points onto other points of S2. Okay, again I am telling that please feel free to contact on this number if you have any mathematical doubts or any preparational doubts. So please feel free to contact. Okay, thank you guys.